All right, the rectangle is probably one of the simplest area situations. There is usually a little confusion about some of the terms of length and width or base and height. And I guess I would say that the general accepted definition of a length is the longer side and that the width is the shorter side. So if you were drawing a rectangle like this would basically be the length and this would be the width. We also refer to base and height. And when we talk about base and height, length and width, what I want you to really understand is it doesn't really matter. Base and height will always be perpendicular to each other, same with length and width. So here's a length, here's a width, they're perpendicular from each other. A base and a height, we get those references, or a height and a base, does not matter. Because these are all perpendicular to each other, these are perpendicular relationships, the name really doesn't greatly matter, but these are the correct ideas or definitions of that. But you are aware, I am sure, that it is just simply base times height or length times width. Those are the same discussion, aren't they? Length times width, base times height. And both of those calculate the squares that are inside of this. This is the whole idea of the array that is formed. Again, I'm not going to spend much time at all really talking about rectangles because, you know, our area model is defined basically by squares, right? We talk about, you know, centimeters squared, and that's because those squares are formed and then basically counted out. And I referred to the array, which just means, you know, 2 rows by 6 columns make 12, right? It's a simple multiplication. Here we have 8 going this way by 4 going this way, gives us 32 overall. So our formula becomes something very simple. It's just base times height or length times width. And this works out nicely because of that perpendicular relationship. I'm going to move to the parallelogram now because it's a little more interesting than the rectangle. The first thing to discuss is that the parallelogram is quite a different shape than a rectangle, and you cannot simply just take one side of that parallelogram and multiply it by the other side. That does not equal the area. So be aware that that is not an option. Now, what is an option, though, is if you take a look closely at what we call the dissection method. Here is our parallelogram, and we've dropped down a height here, which is important. We need heights when we calculate area. And we notice something cool, that this little area right here, we could dissect it, which means to cut it. And if we were to cut it off, cut that area away, here it is here again, it could move quite easily from this spot over to this spot. And as you can see, that would form a brand new shape right here. Hey, wait, that's a shape that you and I recognize, isn't it? That shape right there is a rectangle that we've formed. Now, how does the rectangle work compared to the original parallelogram? It's very cool, is that base didn't change, did it? The piece that we took from here got added here, so the same base. And the height is unchanged. And so we know how to find the area of a rectangle. It's just base times height. And so guess what? When you're doing a parallelogram, you can just simply multiply its base times its height. So while it is not a rectangle, its formula is the same because you can convert any parallelogram basically into a rectangle of equivalent area with the exact same base and height as the original. So using that information, let's do a little bit of solving. Now this first one has a very weird kind of look to it. Here would be a side of 8. And we notice that the other measurement is perpendicular to it, so that would be a height of that. So while that may feel a little uncomfortable, the area is just simply 1 base times the height, which in our case would be 8 times 10. And so that's just simply 80 centimeters squared. Because we are in area, we're tracking things in how many squares we have. 2 dimensions, because we're finding the interior of that now. In this case, here again is a side. And the good news is that, well, wait, we need some more news. We do not have a height, but we get some clues. We see that the slanted side is 5 root 2. We see that there's a 45-degree angle in there. And you and I, in a previous section about special right triangles, learned that we would divide by root 2 to get these pieces. So actually, we find that height to be 5. And I'm ready to go because the area equals 1 base times the height. The base is an 11. The height we found is 5. And so this is 55 centimeters squared. 1 base times the height, and we get the area of the complete region there. Some students keep thinking, oh, I got to cut and move things around. No, you don't. The formula takes care of that for you. It understands that every parallelogram turns into a rectangle of the same base and height. Here we go, one last group. Let's try these 2. Now, this first one is a composite, is what they call it, and that just means you could cut it into things that are easier for you. This is 6 and 6, so this is 36 as an area. This, of course, you see is 8. Now, what's this length from here to here? Well, it's a total of 12, but 6 has been taken, so that would leave us with 6. And so this would be 48. And if we add 48 and the 36, we would just say this is 84 centimeters squared. Now here I have a side, or a width, I guess we would say, but I'm missing its length, or the base, or the height. The Pythagorean Theorem. I'm starting to get used to these numbers. I hope you are too. This is a 5, 12, 13. When I solve this, I get 12. And so my area of this rectangle here would be base times height, which is 5 times 12, which is 60 centimeters squared. These guys are quite simple, just 2 numbers multiplied together. The only work that you have to do is usually find a missing height or something like that, but that's fun. Good luck.